everyone, we are the Group 4.
Hello!
I'm Lauren G. Alindada.
And I'm Mark Joby Asido. And I'm Angelo B. Bunag.
And now we are going to represent our experiment.
Okay.
And here are the materials that we are going to use in this experiment.
First is the vinegar. Second is the plastic cup. The third is food coloring. And the fourth is spoon. And the last is the baking soda.
Wait a minute! Who are you?
As the first step, we need to mix the vinegar and the food coloring together.
Nice.
Second step, we need 3 tablespoons of baking soda to put on the plastic cup. And for the third last step, we're going to put the vinegar on the baking soda and let's see what happens.
No. Wait.
How did that happen?
The experiment shows a visual presentation of chemical reaction of our acetic acid and sodium bicarbonate. Baking soda is sodium bicarbonate. Each molecule of baking soda contains a sodium atom, a hydrogen atom, an oxygen atom, and a carbon dioxide molecule. Vinegar contains acetic acid, each molecule of which contains a hydrogen atom and an acetate ion. When combined, the hydrogen atom in the acetic acid meets up with the hydrogen and oxygen atoms in the baking soda to form a molecule of water, while the acetic ion grabs onto the sodium atom and forms a salt, sodium acetate. The carbon dioxide molecule, free of its other chemical bonds, can now escape and bubbles forth as a gas. When acetic acid is introduced to an aqueous sodium bicarbonate solution, an acid-base reaction occurs resulting in the production of sodium acetate, salt, and water, as well as the release of carbon dioxide.
Intermolecular and intermolecular forces. So sodium bicarbonate molecule feature one sodium cation and one bicarbonate anion. Here an ionic band is formed between the positively charged sodium ion and the negatively charged oxygen, which is singly bonded to the central carbon and not bonded to a hydrogen atom. The lines connecting between the elements hydrogen, oxygen, and carbon, those lines are what represents the bond between each element. The singular lines are the singular bond and the double lines are the double bonds in the singular bonds. There are 2 electrons making each outer shell orbit of the atom to become complete. This means that the compound or acetic acid is covalent bond. After we mix these 2 ionic and covalent bond, they produce a water. A water is a H bonded with a strong intermolecular force. Large amount of energy is required to break this hydrogen bonding. Therefore, water molecule will have high boiling point. Another product is a carbon dioxide gas. Carbon dioxide is a linear and non-polar molecule, so the only intermolecular force present in carbon dioxide is London dispersion forces or van der Waals forces. The molecule had a weak to no attractive forces. And sodium acetate, which is not clearly seen in the video because it is hygroscopic, it literally dissolved in the water, which is also a product of the mixture. It has van der Waals forces or London dispersion forces of attraction. Sodium acetate, which is a conjugate base of acetic acid, is an ionic compound. The sodium ion form an ionic bond with these acetate ions. The ionic interactions are the strongest forces. Therefore, the sodium acetate has the higher melting point compared to acetic acid.
Properties of solid and liquid. Sodium bicarbonate is a white solid that is crystalline, appears as a fine powder. Vinegar is a liquid substance. Acetic acid is a colorless liquid with a sour taste, low viscosity, and strong pungent smell. Properties of solution. The baking soda and vinegar mixture is homogeneous. Vinegar will be the solvent because it will be the substance that the solute will be dissolving in. Of course, the solute is baking soda, or the substance that will be put inside the larger substance.
The concentration of solution. Mole fraction and percentage of 3 tablespoons or 42.6 grams of sodium bicarbonate to 75 ml or grams of acetic acid. Now let's find out the mole percentage of our vinegar and baking soda in our solution. We had 3 tablespoons or 42.6 grams of sodium and 70 ml or grams of vinegar. First, let's find the mole fraction of our solute and solvent. 42.6 grams of sodium bicarbonate divided by the molar mass of sodium bicarbonate, which is 84 grams per mole, is equals to 0.51. For our acetic acid, the given 70 grams divided by its own molar mass, which is 60.1, is equals to 1.17. Now let's add to get the total molar fraction. So 0.51 divided by 1.17 is equals to 1.68. Now let's solve for moles to get the percentage. Mole of the sodium bicarbonate is equals to mole of sodium bicarbonate, which is 0.51 over the total mole 1.68 equals to 0.30 times 100. So the percentage of our sodium bicarbonate in solution is 30%. Mole of acetic acid equals to mole of acetic acid 1.17 over the total mole of 1.68. So the total is 0.670 times 100. The percentage of our vinegar in solution is 70%. This solution had a great and high concentration.
Phase change. Vaporization is the phase change that happened in that experimentation, how the bubbles that was emitted after we mix our vinegar and baking soda releases carbon dioxide, which one of the byproduct in this reaction. The product of chemical reaction are water, sodium, acetate, and carbon dioxide gas.
Additional infos and facts about baking soda, vinegar, and the mixture of baking soda and vinegar. So first, baking soda. It is used for cleaning sinks and basins because of its cleaning properties. It helps in tackling acidity. It is also used in fire extinguishers because it manages to produce a foam which is soapy and comes in when dousing flames. It is used in skincare, baking, and other personal use products. Sodium bicarbonate has a well of history, stretching thousands of years ago. French chemist Nicolas Leblanc made sodium carbonate in 1791, which was also known as soda ash. In the late 18th century, sodium bicarbonate was discovered as a leavening agent by bakers John Dwight and Austin Church in New York. So the vinegar is an acidic liquid produced through fermentation. It is made through the fermentation of ethanol alcohol. Any ingredients containing ethanol may be used to make vinegar, including distilled grain alcohol, wine, champagne, beer, cider, and more. Vinegar has long been used worldwide as a basic seasoning in the preparation and cooking of certain foods because its sharp taste make it so useful and versatile. Also, because of its acetic acid content and low pH, vinegar is used as preservative for both domestic use and in the food industry. It is in fact used for the preservation or pickling of a wide variety of foods such as vegetables, meat, fish products, and spiced fruits. The word vinegar derives from the Old French vinegar, means sour wine. Vinegar was a condiment and for conservation by the Babylonians around 3000 BC. Traces of it also have been found in Egyptian urns from around 3000 BC. The Romans used to think posca, or a mix of water and vinegar that was sold in the streets. Posca was believed to give strength, while wine would make you drunk. So, the use of the mixture of vinegar and baking soda in cleaning. So, it is used to clean pots and pans, clean the dishwasher, clean the washing machine, unclog the drain, making glow to sparkle, cleaning the kitchen sink, to deodorize the toilet, revitalize towels, and many more.
Thanks for watching!
Sa science o agham, tayo na sa sineskwela. Tuklasin natin ang siyensya, buksan ang pag-iisip.
Sa RPD ang pumunta.
Hindi gumagana, ma'am.
Loko lang pala tayo ni ma'am eh.
Sabi ni ma'am, ang dali lang daw. Yung example niya lang pala madali.
Hello?
And here are, di ba hindi kita? Hello Okay.
Sisignan lang kita pa.
And here are the materials that we are going to use in this experiment. Ang pangit nun.
Hindi nga, ayun niya, mag-zoom out.
How did that happen? Putik yun.
Mga 3 step lang.
Sige na, try. Okay, 1, 2, 3. Magkakaawa kamay nyo.
Tayo na sa sineskwela, tuklasin natin ang siyensya.